Welcome back, students. Now what we are going to learn here is, so in the next step, while of count less than or equal to n. Initially count is initialized to 2, so 2 is less than or equal to n. This condition will be true. Okay, then minimum is equal to 999. So here we are going to run two for loops. Minimum we are initializing it to infinity, and we are going to run two for loops. You can see here. So first for loop will be run to select the next vertex. Which is the next vertex we can able to select. We will list out all the vertices among which is the minimum distance that we will be computing. Okay, if of distance of that particular vertex is minimum, then we will consider that particular vertex and we will mark that vertex is visited and we will increment the count. So this will be happening with the first for loop. The first for loop basically used to select the next vertex which can able to reach from that particular newly visited vertex. Okay, so from the vertex 1, right now the vertex 1 is considered as source vertex. From the source vertex you can able to reach to this particular vertex. Okay, vertex number 2 or vertex number 3, whichever the vertex you can able to visit, that will be recorded in the first for loop. The second for loop is used to find is there any other alternate path to reach the next vertex. Also, whatever the vertex you have considered, whether that is giving the minimum weight or not, that both condition will be checked. So select the next vertex from the recently added vertex with minimum weight. If there is any alternate path and you can able to find the minimum weight, that we are going to record with the help of the second for loop. So let us see how this particular set of instruction is going to get executed. So once you are going to run this, so count is equal to 1, while of 2 less than or equal to 5, condition is true, minimum is equal to 999. Here you can able to see I have written loop 1. It indicates that the first loop is executing for certain amount of time. W is equal to 1, W1 is less than or equal to 5. Okay, so this condition is going to get executed. Below that I have written loop 2. It indicates that this is the statements are going to get executed whenever loop 2 start initiating and executing. Okay, so first let us start with the loop 1. So W is equal to 1, 1 less than or equal to 5. Condition is true. So once the condition is true, inside the loop you have one more condition stating that if of distance of 1 less than 999. So you have just listed out what are all the distance are present for the particular array. Okay, initially distance of 1 less than 999 and visited of 1 is equal to 0. So distance of 1 means distance of 1 is 0. To reach the vertex number 1, you don't have any distance. So distance you are recorded there as 0. So 0 is less than 999. This condition is true. But visited of 1, already the vertex 1 is visited, that we have seen in the previous video. Okay, visited of 1 is equal to source of visited of 1 nothing but visited of SRC. Source vertex we have considered as 1. That's why it is equal to 1. 1 double equal to 0. This condition is false. If the condition is false, we will increment the value of W. W is equal to 2. 2 less than or equal to 5. Now start checking if of distance of 2 less than 999 and visited of 2 double equal to 0. So both the condition you are supposed to check. This is the condition. Visit distance of W, nothing but what is the W value, less than 999. Minimum value is 999 currently, and visited of W, visited of 2 double equal to 0. So 4 is less than 999. Distance of 2 is from the vertex 1 to 2. You have a directed path with the distance 4. So 4 is less than 999. Minimum value, condition is true, and still second vertex is not visited. So that's the reason 0 double equal to 0. If it is already visited, so then it could have become 1. So now it is 0. 0 double equal to 0. Condition is true. So if the condition is true, we will need to update the minimum value. Minimum is equal to distance of W. Distance of 2. What is the value? 4. So that value we are updating in the variable called as minimum, and V is equal to 2. It indicates that this is the vertex I have visited recently. This vertex I am going to consider for my iteration. So this is not the end. You need to run the loop and you need to check whether this is the minimum or any other vertex I can able to reach with minimum distance. Okay. So W is equal to 3. 3 less than or equal to 5. If of distance of 3 less than 999. No, not 999. You should write the minimum updated value as 4. So distance of 3 is 999 less than 4, because distance vertex 3 cannot be visited from vertex 1. So 999 directly. Okay. 999 less than 4, condition is false, even though that vertex is not visited. Since you have logical AND here, one condition fails, it is false. Then W is equal to 4, 4 less than or equal to 5. Distance of 4 is 8. Even though you don't have a direct edge from vertex 1 to vertex 4, the value here is 8. 8 is less than 4, condition is false. 0 double equal to 0. Even though the vertex is not visited, we can't consider. Similarly, weight of the W is equal to 5. distance of 5 is equal to 999. Since you don't have a direct edge, less than 4 false, 0 double equal to 0 condition is true. Once condition is only one condition is false, it is false. So soon after this, you have two statements. Visited of 2 is equal to 1 means second vertex I am going to consider. So second vertex I have visited successfully. Then the value of count is equal to 3, because this is our condition where this is our anchor condition where our algorithm execution is going to stop. Count is less than or equal to n. Okay. So count is equal to 3. It is done. Then now I am executing the loop number 2 because I want to find from the vertex 2. I have any other alternate path that I want to find. So let us see. So w is equal to 1, 1 less than or equal to 5. If of, now I am running this particular condition, if of distance of w, distance of 1 greater than distance of 2 plus cost of 2 plus 1 means vertex is 2, v value is equal to 2, recently visited vertex is equal to 2. Okay, then w is 1, 2 to 1. From the vertex 2, can I able to reach all the remaining vertices? I am going to check. Okay, so 4 plus 4 it is false. Once w is equal to 2, let us see, w is equal to 2, this condition is also false. This condition is also false because distance of 2 is 4 greater than 4 plus 0, that is also false. Okay, once w is equal to 3, if of distance of 3 is 999, distance of 3 is 999 greater than distance of 2 was 4, then cost between the 2 to 3 means vertex 2 to vertex 3 there is a edge with the cost 3. So 4 plus 3 is 7, 999 is greater than 7. So that's the reason the new distance, because we don't have a previous value for our given graph. Let me show you back again whatever the graph we have considered. So you can observe 1 to 2 I have a edge, this I have found it first. From 2 I can able to reach to 3. So 4 plus 3 it is equal to 7. Okay, so that is what we have written in this particular statement here. 7, 4 plus 3 is equal to 7, distance between 2 to 3. So now path is equal to 2. From the vertex 2 you can able to reach 3. From 1 you can able to reach 3 via the vertex 2, in between the vertex 2. So that is why we have written path from the vertex 3, vertex 1 to vertex 3 is 2. From vertex 2 we can reach. Okay, next w is equal to 4, the same loop is going to run. W is equal to 4, 4 less than or equal to 5, condition is false. Sorry, condition is true. If of distance of 4, 8 is greater than 4 plus 999, false, w is equal to 5. So this is how the loop is going to end. Okay, again what basically we are supposed to do, count is already get incremented, count was become 3. So 3 is less than or equal to 5, condition is true. So you need to run the loop 1 and loop 2 in the same manner. So in this particular case, the vertex 3 is going to get visited in this iteration. When loop is, when count is equal to 4 again. So 4 less than or equal to 5. In this condition, okay, so you are going to find the vertex 4. So vertex 4 is going to get visited. Okay, but vertex 5 you can able to find the distance in the second loop condition. So similarly, if you run the loop again, loop 1, 5 less than or equal to 5, loop 1 and loop 2. So you can able to find the minimum weight for vertex 5. So loop 2 you are going to run over here. So once after executing all these condition, so finally we are going to call the path function. Static void print path function that you are going to find. Okay. So once you are going to call this particular method, w is equal to 1, 1 less than or equal to 5. You can observe here, I have written here, if of visited of 1 double equal to 1. Okay, visited of 1, all the vertex need to be visited, then only I can able to print the path. Okay, w not equal to sv. W is 1 not equal to 1. Not equal to 1 means source vertex. Source vertex is equal to 1. If this condition is satisfied, then only I can able to print the path, because for the source vertex there is no other path. It is a parent node. Okay. So this condition is false. So we will not execute the if condition. Simply we will increment the w. W is equal to 2. 2 less than or equal to 5. So 1 is equal to 1, because visited of w is equal to 1. 1 is equal to 1. Similarly 2 not equal to 1. Where w is equal to 2, 2 is not equal to source vertex. So we will enter, we will print the message, the shortest distance between, okay, 1 to 2. SV is 1, 1 hyphen, okay, followed by arrow is equal to w. W value is equal to 2. Is distance of w. Distance of 2 is what? 4, that we are going to print. Then integer t is equal to path of w. Path of w is what? That is nothing but 1. So the path is 2 to 1. The path is, you are going to print here, value of the w is equal to 2. So here you are going to check T not equal to SV means if there is a straight path, directly we are going to print it at last. If there is any alternate path, that we are going to run with the help of a looping construct. Okay, with this while loop is used to find any other intermediate node we have used. Okay, T, what is the value of the T? T value is equal to 1. 1 not equal to source vertex is equal to 1. This loop is going to fail because this T is equal to, because we have a directed path. So finally we'll come to this statement, system dot out dot println SV, source vertex. You are going to print only this much. So 2 to 1. So 2 you are going to print here, 2 to 1 you have a directed path. Now let me go for the next iteration. W is equal to 3. 3 is less than or equal to 5. Condition is true. Visited. The vertex 3 is visited. Okay. Then 3 not equal to source vertex. Fine. Though here what you are going to print? Source vertex is 1. Between the 1 to 3 means W is equal to 3. Between the vertex 1 to 3 you can able to reach with the cost 7. This 7 how you have got? 1 to 2 was 4 plus 2 to 3 was 3. So 4 plus 3 is equal to 7. So that's why the path is you are going to print system.out.println. First you are going to print the W. W is 3. So once after printing the 3, okay. So here it is going to check the condition T not equal to SV. What was the T value? T value means path of W. Path of W means path of 3 is equal to 2. So that value you are going to get 2 not equal to source vertex. Condition is true. System.out.println, one arrow you are going to print followed by what is the value of T. T value was 2. That 2 you are going to print here. Again you will specify T is equal to path of T. So what is the path of 2? It is 1. So while loop again check the condition T not equal to SV. Now the value of T will become 1. 1 not equal to 1, condition is false. You will come out and you are going to print system.out.print one arrow followed by SV. SV means 1, source vertex. So to reach from 1 to 3 you are traversing in this path. 1 to 2, 2 to 3. This is how you are going to print. So similarly W is equal to 4. Since you have a direct path 4 you are going to print here. Immediately this while loop will not get executed and you will print 1. But from W is equal to 5. For W is equal to 5, 1 to 5 you have a path between 1 to 4, then 4 to 1. 1 to 4 you have a direct path. From 4 to 5 you are going to traverse. This is how your Dijkstra's algorithm is going to work. Please execute this program. I am sending the program also. Please execute this program. Have this tracing part along with the program. Then if you have any doubt, feel free to post a question. We will reply. Thank you.